Okay, so today, well, so let me just give you a preview for this week. You guys all have your calendars, but I'm gonna give you a preview. Well, we're gonna talk about radians and degrees and how they're interlinked with each other. I think we're familiar with degrees, but then radians, we may have not seen that as much. So we're gonna kind of see how they correlate with each other. Tomorrow we'll talk about arc length, and then terminal angles, reference angles, and this is all leading towards unit circle, which we're going to get to after this next quiz. So we have a quiz Friday, just over what we go, just going over what we cover this week, and I hope to try to cover a little bit more than what is assigned each day. So when we get to Thursday, we have a chunk of time that we can devote to quiz review. Okay. I haven't finished grading your quizzes. Hope to have that for you by Wednesday. Okay. Yeah, so that's the goal. Hopefully I get it back to you by Wednesday. Okay. Okay. So let's go to page 16. Okay. We're skipping over 1.05 radian investigation. We're going to just kind of go over that in detail on the next few pages, but we'll start on page. Okay, give me 1 second here. All right. Okay, so an angle is formed. Going over some definitions first. Angle is formed by two rays that share a fixed point known as the vertex. Okay, so we all know what an angle looks like, and right, we have two rays. Right, ray is kind of a cross between a line segment and a line. There's a starting point, and the other side is going to continue going without end, denoted by an arrow. And the vertex is the sharp point of the angle. Okay. Right. So one of the rays is fixed from the initial side. So typically, we like to read an angle starting at the zero angle, starting at the positive x-axis side, and then we usually measure angles counterclockwise. Okay. And so the initial side is the starting side there. And the terminal side is the ending side. Okay. So an angle is formed starting here and ending here. So we call this the terminal side. An angle with its vertex at the origin and its initial side angle, initial side along the positive x-axis is in standard position. So we call this angle measure standard position. Now, any angle that starts on the x-axis and moves clockwise, we call that a negative angle measure. So, if this is 30 degrees this way, this will be positive 30. If this is also 30 degrees going this way, because we're going the other direction, that's a negative angle measure. All right, we want to know the quadrants and signs for x and y in each quadrant. It's very important in trig. Degree or angle measures are read with respect to the quadrant starting at the positive x-axis, moving in the counterclockwise direction. So, so anything in quadrant 1, your order pairs will have a positive x and a positive y. Anything in the second quadrant, your order pairs will have a negative x and positive y. Anything in the third quadrant, negative, negative. And anything in the fourth quadrant, the order pairs will be positive x and negative y. So think of this as going around in the full circle. And I think we understand, we've seen this a lot, right? 360 degrees kind of relates to a full circle. And if you take a full circle and split it up into 4 parts, we call them quadrants. Okay, so imagine splitting that 360 divided by 4. That means we're going to keep incrementing by 90 degrees all the way around the circle. So if this is 0, this is 90, plus 90 will be 180, plus 90 will be 270, plus 90 will get you to 360. Okay, if the terminal side of an angle falls on one of the axes, then that angle is called a quadrantal angle. Okay, we have 4 quadrant angles on the unit circle. So 0 and 360 talks about the same angle measure, but 360, basically we circle back to our starting point. And so 0, 360 refers to the same positive axis. Okay, so we talked about this, 90 degrees on the y-axis, positive y-axis, 180s on the negative x-axis side, and 270s on the negative y-axis side. Okay, so more vocabulary that just as review, as we're going to see these terms come up again. Right angle is an angle whose measure is exactly 90 degrees. So sometimes we use a corner box to help indicate that we're looking at a 90-degree angle and not at an angle that is slightly acute or obtuse. Speaking of those, acute angle is an angle whose measure is less than 90 degrees. There's an example. Obtuse angle is angle that is greater than 90 degrees, more than a right angle. Okay, so complementary angles are 2 angles that add up to be 90 degrees. So just drawing an arbitrary middle angle here. So angle 1 and angle 2 will be complementary because we know that those 2 angles added together will form a right angle. So angles 1 and 2 are complementary. Supplementary angles are 2 angles whose sum adds up to 180. So we can also think of 180 as forming a straight line. So let's say I have an obtuse angle, angle 1, and acute angle, angle 2. We can tell that angle 1 and angle 2 is going to form, added together, will form a straight line. So that's 180 degrees. Angles 1 and 2 in this case would be, we'll consider these, the relationship is that they're supplementary. Even though we may not know the exact angles, by looking at them, we know that they must add up to 180. They're both, they're supplementary angles. All right, next page. All right, we have a new unit of measurement for angles, and it's called a radian. Okay, so a radian is the measure of an angle in a circle whose intercepted arc has a length equal to the radius. Okay, let me talk about what that means in a second. So we may recognize the term circumference. So circumference is the length around a circle, okay? Distance around a circle. So if you were to put a string around a circle and then measure it, put it up against, straightening it out and putting it against a ruler, that distance is the circumference. Okay? Circumference is always going to be 2 pi r. That's always going to be the relationship there. So there's a relationship between the radius of a circle and the distance around the circle. Let me just go through these notes here, and I'll bring in the other sheet that hopefully will help us kind of understand what a radian is. So we know that okay, so about the center of a circle is 360 degrees. So that just means, if we were to go fully around a circle, that's 360 degrees. And then the center of a circle is 2 pi radians. Okay, so if we go about the full circle, that's 2 pi radians. So 360 is equivalent to 2 pi radians. Okay, now let me talk about what a radian is. Okay, so I'm going to bring in the other sheet here that you guys picked up. So again, 1 radian is the angle measured at the center of a circle by an arc that is equal in length to the radius of a circle. So let's just pick any random circle. It doesn't matter what the radius is. So the radius could be 1 inch, could be 4 meters, could be 2 kilometers. But whatever that distance is, okay. Let's just say that it is 1, okay, and we'll talk about unit circle later. But let's just say that distance is 1. Okay, so let's just say we measure the distance of that radius distance from the center to a point on a circle. It's going to be the same distance all the way around, right? If it happens to be a radius of 1. Now let's take that distance, okay, and let's put it straight up along the edge of a circle. So I'm going to take, so imagine it's a string or some flat length that you're able to kind of move across. Okay, so let's just say that this is still the radius, right? That's the same length as this. Okay. Now, let's say that is a string that you're able to kind of fold along the circle. So I'm going to highlight what I'm doing here. So let's say we have that distance. We put it up against the edge of the circle, and then we folded it along the edge of the circle. Okay. Now, whatever that value is, okay, whatever that angle measure is, that is formed by that radius kind of curved along the circle, that is 1 radian. So that measure is 1 radian. Okay, doesn't matter how long the radius is, the angle measure will always be the same. So if it's a longer radius, then it'll go along a longer circle, a larger circle, but the angle measure is always going to be 1 radian. So imagine you take that 1 radian and you make your way around the circle. Okay. So right, let's say this is 1 radian, right? And I'm just putting that same length around the circle, 2 radian, 3 radian. Now, is 3 radian equal to 180 degrees? Slightly less, right? Slightly less. And that is where 3.14 comes in, right? It is 3 and change. And so 3.14, you guys recognize that? What is that equivalent to? Pi. So pi is talking about a full, so pi is equivalent to 180 degrees, because if I put 3 radians along the edge, along the path of the circle, it's always going to be a little less than 3, but we know that 3.14 is exactly half a circle. Okay, so that's where that pi comes from. It's related to radius and moving along the circumference of a circle. Okay. So radian, or pi, sorry, pi is exactly half a circle. Okay. So if we keep moving along the circle, right? So 1 radian, 2 radian, 3 and change. Okay, we keep going here. 4, 5, 6 and change. So 2 pi radian is going to be exactly 360 degrees. Okay, so that's what a radian is. Radian, we start with the radius, and then you take that radius and you fold it along the circle. It doesn't matter how large that radius is. It's always going to take 6 radians to make your way around the circle, or 6 and change. So that's why that pi is. All right, so here's the conversion rate. We know that 2 pi is equivalent to 360 degrees. So if we just divide it in portions, then we're always going to be able to create this relationship between radians and degrees. So we know that 180 degrees and pi are equivalent to each other. So anytime I want something that is in degrees, I take whatever the radian measure is and convert it. So I basically get rid of the pi, involve the degrees. So 180 over pi will get me the equivalent of that radian measure in degrees. Same thing, if I'm sitting in radian form, I can get it into degree measure by getting rid of the, or involving pi, and I'm able to, if I divide by 180, I can cancel that out. But we know that 180 and pi are equivalent, so essentially I'm multiplying by 1, but I'm getting it into the appropriate version. I think right now we're familiar with degrees, but it's just going to take some time to match up radians with degrees. But it's okay for now, where we're always thinking in terms of degrees, but eventually we're going to see radians enough where we're not going to have to do that conversion every single time. Okay, so let's go to back to the middle of page 17. And let me go through some examples, and then we'll practice a little bit with the problems below. So if I want to convert from degrees to radians, okay, and we state the quadrant in which the angle lies. The 120 degrees is going to be in the second quadrant because it's more than 90, but less than 180. We know that's in the second quadrant. If I want to get this degree measure into radian form, I'm going to multiply by pi over 180. So basically, I don't want the degrees. I want to find the equivalent in terms of radians. So that means I want something that has pi in it. So I'm basically going to multiply by pi over 180. That's going to get my degree notation to cancel out, and then I'm be left in terms of radians. We can use our calculator if we like, or we can kind of just reduce on our own. So I like to put the numbers together, and then I like to put the pi next to it. You can put the pi in the numerator, or you can put the pi outside. It means the same thing. Times pi is going to be as 120 pi over 180. Yes. Why is it cancel degrees? Okay. So the reason why is because, let me go back here. So if our units are the same above each other, we can cancel them out. So this is really 120 degrees multiplied by pi radians over 180 degrees.
When I put in the calculator, 2 pi over 3.
2 pi over 3. Okay. So we're going to reduce that in a second, but I just want to. The question right now is, why does it change over to radians? And the reason why is because I'm multiplying by pi radians over 180 degrees. We know that these are equivalent, so I can make them above each other. And you know that anything in numerator and denominator can cancel out, so that's why degrees goes away, and we're left with radians. Okay. So now 120 over 180, you can use your calculator, leave the pi out of the calculator, just reduce the coefficient. And that will take you to, like you said, 2 over 3. So we know that 2 over 3 pi radians, sorry, is the equivalent of 120 degrees, just using a different measurement name.
On the outside,
I'm sorry?
it has to be on the outside.
It can be on the outside. It can also be with the two. These are equivalent. They mean the same thing. Okay. So 2 pi over 3 is the same thing as 2/3 times pi. 2/3 pi radian. So it's up to you. Just know that they are equivalent. And sometimes I may write it one way, I may write it a different way, but you can choose either way to write it or mix and match. Yep.
It's not to be like 1 pi over another number, could you just write pi over that number?
Yes, that's right. You can say if it's 1 pi over 3, you can write pi over 3 because you can drop the 1 or leave the 1 there. It's up to you. Okay, good. Next up, now let's go the other direction. Okay, if I'm sitting in radians and I want to convert it to be a different unit or different measure or different form, still means the same thing, still the same measure, just different form. We're now going to flip our conversion. Okay, instead of pi over 180, now we want 180 over pi. So if I'm sitting in radians, usually the pi is going to be showing up, and I want to get that converted to be, what does that mean in terms of degrees? Then I multiply by 180 over pi. And sorry, go ahead. At the end you can, at the end, but as you're doing the conversion, you don't have to. The pi's cancel out, and that's what you want. That's a good sign that you're moving in the right direction if you're able to get the pi's to go away. Now we're left with 5 times 180 over 6. You can make the calculator do the work for you. But that's going to clean up to be 150 degrees. You can use that upper notation there, that circle notation and the exponent, or you can say 150 degrees right out the word. Okay, any questions? Yeah.
The degree is above 180.
If the degree is above 180, the conversion will still work. It'll still work, yeah. You're just gonna get a larger number, but it'll still work. So why don't we try some of these? I'll just do the setup for each of them, and then you guys can finish it. Okay. I'm sitting at 30 degrees, so how do I convert this to? It says write each degree measure in radians as a multiple of pi, and each radian measure in degrees. So if I'm sitting at 30 degrees and I want to convert it to radians, what do I multiply by? Pi over. And the way you do this in the calculator, you just do 30 over 180, get that fractional value, and then don't insert pi into the calculator. If you insert pi in the calculator, it'll get you potentially a decimal value that's not exact. So leave pi out of the calculator, just do 30 over 180, and then you're just going to attach pi directly to what you see. So what's 30 over 180 going to be? 1/6. So you can say 1/6 pi, or you can say pi over 6. You can just have pi take over the entire numerator, because 1 times pi is just pi, so either is fine. Typically, we write it as pi over 6, just a little bit cleaner. Yes. Yes, I think down the line, we're not going to have to do that all the time, but I think for now, that's fine. Just so we can remind ourselves which form that we're in. And sometimes we use RAD to represent radians, okay? And then for degrees, typically, you can just not to write out the word, you can just have that that circle notation, that exponent kind of that degree notation. Okay, number 11. We're starting with degrees, so multiply by what? 518. Okay, number 12. Multiply by. So anytime we see degrees, it's all the same thing, right? Now we hold on to the negative, okay? So we don't want to drop the negative. Negative is going to be part of our answer. So we may have negative radians, which is fine. But now we get to 14. We want to convert from radians to degrees. The conversion is a little bit different, right? So now it's times what? You're on the right track if you get the pi's to cancel out. So you want the pi's to be above each other so they can cleanly go away. That's the case for the rest of the problems, right? 14, 15, 16, 17. They're all multiplied by 180 over pi. Okay, so try that. See if you're able to clean that up, and we'll check our answers in a minute or so. Has to be in fraction form, right? And if you're getting a decimal value, you can always use the conversion button to get through. So let's say you're getting 0.333, okay? You can always hit that. There's a fractional button there. So you can do second FD there. And that will convert your decimal back to a fraction. Okay. So there's that button right above enter. You see that F arrow D, that means you're able to convert from a fraction to a decimal, or decimal to a fraction, either way. Graphing calculator, there is a conversion. Okay, the conversion is under math. So math is that first column right below alpha, math, and then here I want to convert to a fraction. So hit 1. That should convert to a fraction. Good. Any other questions?
I know, that's what I got to like a circle.
Right, I'll talk about that. So we're good understanding that full circle is 360 degrees, right? So 450 would mean that we're continuing along the circle multiple times. So, so if I go another 90 degrees, that means I'm sitting at 450. So 450 is same thing as 90 degrees. It's just that, they're going around the circle multiple times to reach that same degree measure. Yes.
Would you want to write 450?
Yes. So right now, you're just going to write it as 450. Down the road, if we want to get it down to something between 0 and 360 so that we can recognize it, we're gonna do something with that number to whittle it down to something that we recognize. But right now, 450 means that you're going around the circle multiple times to reach a degree measure that is equivalent to something else, which in this case is 90 degrees. But for now, you can just leave it and that down. So anything greater than 360 or less than negative 360 means that you're circling around more than one time around that circle in whichever direction. Good. Any other questions? Okay. Everybody good here? Because I like to get a head start in the next section, if we can. But I want to make sure we're all comfortable with converting from one form to the next. You're either multiply by pi over 180 or you multiply by 180 over pi. Okay, good. All right, let's go to page 18. Okay, we'll skip the review. We just did that, right? Well, I'll just go through these real quick. All right. 315. If I want to convert to radians, what do I do? Good. And you're always going to leave pi out of your calculator and just attach it after you get that fraction. Likewise, I want radians to degrees. I want the pi's to go away. So I know I want the pi below. Okay. Next up. We're going to talk about arc length. So arc length is if I were able to take the distance around the any part of my circle, and if I were able to take that string and put it against a ruler, what would be the length of that distance? So if theta is measured in radians of a central angle, so central angle means that the vertex is sitting in the middle of the circle. With the radius r, then the length s, so that's the notation for arc length, is given by s equals r theta. And the thing we have to be careful about is the theta must be in radians. So if your theta is in degree form, you've got to convert it first into radians before this formula can work. Okay. This formula only works if theta is in radians. So if theta is in degree form, then you got to make sure you multiply by pi over 180, get into radian form, and then you're able to have something to insert for that theta. So if I want to find the arc length, meaning if I want to find what is the distance of a side length that is related to the angle measure. I want to find the distance of this curved region and along a flat surface. This is what the formula can do for us. So my arc length, so that's my S, that's notated by this variable S, is radius times theta. So whatever the radius is, okay, usually it'll be given to you in the problem, multiply by the theta that has to be in radian form. So I'll make sure everyone had a chance to copy that down.
Isn't theta be the same value? Or is it because it's
Let's see,
arc
theta
is the
will
same.
be the same value as what?
S, like the arc would be.
Okay, so theta is the angle measure. Arc length is something that's measured in terms of like inches or something
Oh, so
along
it's
the
like straight.
Right, so it's straight, right. So we're taking this curved region and we're straightening it out and measuring that distance.
But if it's still curved, it's the same.
Uh, it's still curved. Yeah, it's still the same value. So imagine you take a string and you fold that string along that curved region, and then you take that distance and you straighten it out and then you measure it. Then that distance would be what this curved length would be. So we have to kind of imagine that the curved region is flexible enough for it to straighten out. And if you were to measure it along a ruler, that's what the arc length would be given.
Like, if you're looking for the radius, would you then like convert the degree to radians?
Yes, that's right. So anytime we want to use this formula, this theta is not built for degrees. If something's given to you in degrees, you've got to take that extra step, get it to radians, and then you can do the formula. This formula doesn't work for degrees. All right, so good questions. Let's look at example 1. So again, let me write the formula above. S is equal to R times theta. So in other words, arc length is equal to the radius times the angle in radians. That's the formula. Arc length equals radius times the angle. Okay, example 1, find the arc length. So we're looking for S. If the radius is 8 centimeters and central angle is 3/4. So this is easy because theta is given to you in radians, so there's no adjustment needed. We can plug directly into our formula. And S equals R theta. R is 8. Theta is 3/4. Any questions here? So you're going to put this in the calculator, or you can work this out by hand. But either way, don't put pi in the calculator. That's okay. I think sometimes some of the calculators may handle it well and keep the pi, but some calculators will just try to convert to a decimal, and we don't want that. So safest way is just put in the fractional value, leave pi out of it, and then once you get the reduced fraction, just add pi onto your paper. Okay, so what's S equal to?
6 pi.
6 pi. Okay. 6 pi. Now we're taking that length and we're measuring it against a ruler, right? So we can have the unit 6 pi centimeters. But just for our frame of reference, because 6 pi kind of seems abstract, right? So that's the exact answer. if I want to get a decimal value so we can kind of visualize what that means in the real world context. Now enter pi in the calculator and let it give you a decimal value. So you'll do 6, and then do you guys see the pi button?
Yeah.
Oh yeah. So here, under that complex sign, if you tap it a couple times, it'll take you to other variables, but if you just tap it once, it'll be pi. Now, I'll still give you 6 pi, but you can hit that fraction decimal button and it'll give you a decimal version. So it's around 18.8 centimeters. So kind of gives us a more on your graphing calculator, pi is located above the division sign. So we do 6 pi. Right. So for now, I would like for us to give the exact value, but then also give a decimal value so that we can kind of visualize it a little bit more rather than just an abstract measurement. Okay, are we good with 1? Okay, try number 2. Yes.
You show how to do pi.
Yeah, graphing or, okay, so on your 36 Pro, pi is right there. You see that first column there, pi. Now, if you hit it, tap it a couple times, you're gonna run through a couple of variables or double notations, but if you hit it once, it'll just be pi. And also, if it doesn't give you a decimal, you can always hit that fraction button, second FD, and that'll convert. That'll give you a decimal value. Oops, it should. Or if you just hit it once, it'll convert it from a to a decimal. So, try example 2. Should be straightforward, like number 1. All right. No questions, 1 or 2?
Do I have to write 10 pi and just get that?
No, yeah. So I want you to write 10 pi centimeters so we can kind of get used to. Sometimes I'll be asking you for exact values. Sometimes I'll ask you for decimal approximations. So I want you guys to kind of get used to both forms depending on what I'm asking for. So 10 pi centimeters will be the exact value. But sometimes the decimal is helpful to give us some perspective, right? Because 10 pi kind of feels like we don't know what that really means. So around 30. So that squiggly lines is to indicate that okay, it's an approximation, not exact, but they're both centimeters. Because these are measurements that we can put up against a ruler. Okay, number 3. Find the arc length if the radius is 2.5 miles and the central angle is 300 degrees. Same formula, but what's the red flag? Yeah. This is theta, but it's theta that needs to be adjusted. You can't do this formula if theta is in terms of degrees. It's got to be converted first. So we got to go through conversion, get the theta that we can use before we can use the formula, before we can use the arc length formula. So how do I convert? Get that theta conversion done first, then you can use the arc length formula. Okay, good. We got a head start into the next section. I'm gonna walk around real quick. I just want to check page 17 and 18. That's okay. So whatever we do in class, if you just show me that you're keeping up on your class credit.
Are you reading them? Are you reading Steve? Yeah. I'm just like, I have to get them. I'm supposed to read that. Really? Wait, you're the mic. Yeah. I don't know if they're good. Yeah. It was just 3 mistakes. Oh, that's not. That's 226. Oh, yeah, nice try. Oh, that's last. And I'm calling my son reading. But I haven't read it all.
Hey guys, come over and grab your phones.
I know you got 4 Francisco 5 or 77. Otherwise, like, probably about what you got.